Shushmita. Let's start today's session with specific heat. What is that? You might have felt that the land is cool in the morning and hot during the daytime. But water in a lake will be almost at a particular temperature both in the morning as well as in the afternoon. Both are subjected to the same amount of heat energy from the sun, but they react differently. How is it possible? In this part, we shall find out. Before that, let's revise the previous topic. Recapitulation. Heat is a form of energy in transit that flows from a body at higher temperature to a body at a lower temperature. SI unit of heat is joule. Its CGS unit is calorie. 1 calorie is equal to 4.186 joule. When two or more bodies are at different temperature are brought into thermal contact, then net heat lost by the hot bodies is equal to net heat gained by the cold bodies until they attain thermal equilibrium. The average kinetic energy of the molecules is directly proportional to the absolute temperature. Learning outcomes. At the end of this lesson, students will be able to learn the definition of specific heat, the unit of specific heat, heat capacity, application of heat capacity, keywords, specific heat, heat capacity, joule, Kelvin, concept map. Hey, we took the example temperature of pond water. Can you guess the reason? It is because both of them have different properties. In general, the amount of heat energy absorbed or lost by a body is determined by three factors: mass of the body, change in temperature of the body, nature of the material of the body. We can understand this from the following observations. The quantity of heat required to raise the temperature of 1 liter of water will be more than the heat required to raise the temperature of 500 ml of water. If Q is the quantity of heat absorbed and M is the mass of the body, then Q directly proportional to M. The quantity of heat energy Q required to raise the temperature of 250 ml of water to 100 degrees Celsius is more than the heat energy required to raise the temperature to 50 degrees Celsius. Here, Q directly proportional to delta T, where delta T is the change in temperature of the body. Thus, the heat lost or gained by a substance when its temperature changes by delta T is Q directly proportional M delta T. From the above equations, the absolute temperature and energy of a system are proportional to each other. The proportionality constant is the specific heat capacity S of the substance. Therefore, S is equal to Q by M delta T. Specific heat capacity of substance is defined as the amount of heat required to raise the temperature of 1 kg of the substance by 1 degree Celsius or 1 Kelvin. The SI unit of specific heat capacity is Joule kg inverse Kelvin inverse. The most commonly used units of specific heat capacity are Joule by kg degree Celsius and Joule by gram degree Celsius. Why is the specific heat different for different substances? We have seen that the temperature rise depends on the nature of the substance. Hence, the specific heat of a substance depends on its nature. If the specific heat is high, the rate of rise or fall in temperature is low for the same quantity of heat supplied. It gives us an idea of the degree of the reluctance of a substance to change its temperature. We know that the temperature of a body is directly proportional to the average kinetic energy of particles of the body. The molecules of the system, body or substance, have different forms of energy such as linear kinetic energy, rotational kinetic energy, vibrational energy, and potential energy between molecules. The total energy of the system is called the internal energy of the system. When we supply heat energy to the system, the heat energy given to it will be shared by the molecules among the various forms of energy. This sharing will vary from substance to substance. The temperature rise is high for a substance if the maximum share of heat energy is utilized for increasing its linear kinetic energy. This sharing of heat energy of the system also varies with temperature. That is why the specific heat is different for different substances. If we know the specific heat of a substance, we can determine how much heat Q is needed to raise the temperature of a certain mass of the substance through certain degrees by using the equation. Q is equal to ms delta T. Applications of specific heat capacity. Watermelon brought out from the refrigerator retains its coolness for a longer time than any other fruit because it contains a large percentage of water. Water has greater specific heat. A samosa appears to be cool outside, but it is hot when we eat because the curry inside the samosa contains ingredients with higher specific heats. Points to remember. The specific heat of a substance is the amount of heat required to raise the temperature of the unit mass of the substance by 1 unit. The amount of heat energy absorbed or lost by a body is determined by 3 factors: mass of the body, change in temperature of the body, and nature of the material of the body. The SI unit of specific heat capacity is Joule kg inverse Kelvin inverse. Among all the substances, water has the highest specific heat capacity. SI unit of heat capacity is Joule by Kelvin.